Today we will learn about the sum of the interior angles of polygons. Now we know the sum of the angles of some polygons, such as triangles. No matter what type of triangle we have, the sum is 180 degrees. For a quadrilateral, the sum is 360 degrees, no matter what type of quadrilateral it is, rectangle, square, non-specific. But what about a pentagon, hexagon, and so on and so forth? What would the sum of the angles be? So here's what we're going to do to help us see this. Okay, we're going to draw all the possible diagonals from the indicated vertex on each polygon. Okay, so indicated vertex. Well, there are no other diagonals to draw in there. Okay, in this quadrilateral, from that vertex, we'll draw a diagonal there. Now, of course, there's another diagonal, but we're only worried about the diagonals from that one vertex. Okay, in this pentagon, we will draw a diagonal here, and then right here. Okay, from the hexagon, we will be drawing 3 diagonals. This would be a good time to pause the video and finish the rest of the images yourself. When you're finished, your worksheet will look like this. Now, the pattern here, notice that as the number of sides increases, how many triangles do you see inside each polygon? Okay, the table helps lay that out for us. Okay, so the number of sides of a polygon. How many triangles do you see, and what would the sum of the angles be? So, in a triangle, there's one triangle, sum is 180 degrees. In a quadrilateral, there are 2 triangles, and the sum of the angles in this triangle plus the sum of the angles in this triangle is 360 degrees. In the pentagon, we have 3 triangles. If we were to add up the measures of all of the angles in that pentagon, one triangle of this triangle, that triangle, we would get 540 degrees. In the hexagon, there are 4 triangles, and if we were to add all of the angles inside each triangle, and we know it's 180 in every triangle, we will get a total of 720 degrees. And if we had 7 sides, excuse me, if it was a heptagon, we have 5 triangles, and the sum of all of those angles would be 900 degrees. You could pause the video and fill in the rest following the pattern that you see. When you're done there, your answer should be this. Now, pattern. As the sides increase, what do you notice about the number of triangles? Think for a moment to yourself. Hopefully you see that the number of triangles is 2 less than the number of sides. So I take the number of sides minus 2, that tells me the number of triangles. Well, how do I figure out the measure of the sum of the angles in there? Well, if I have 2 triangles, 2 times 180 makes 360. 3 triangles, 3 times 180 makes that. So I take 180 degrees times n minus 2, and that will figure out the sum of the angles of any polygon. Okay, so down below, compare the number of triangles to the number of sides. Do you see a pattern? The number of triangles is 2 less than the number of sides. How can you use the number of triangles formed by the diagonals to figure out the sum of all the sum of the angles, interior angles of a polygon? Well, multiply the number of triangles by 180 degrees. Okay. The expression we just wrote up here is 180 degrees times n minus 2. So the number of triangles times the number of degrees per triangle. Okay, so this is the justification you're going to write down every single time. Okay, kind of a long one, but oh well, you guys can handle it. Okay, you're going to write sum of interior angles of an n-gon is 180 degrees times n minus 2. We say n-gon just to be in general for some polygon with n sides. Okay, so this is what you're going to write down every single time you solve for some part of the angles inside of a polygon. Okay. Let's do some practice here. Okay, so first thing you got to write is we're solving for the angles inside of a polygon here. So we're going to write the sum of interior angles of n-gon is 180 degrees times n minus 2. So we're going to add up all of the angles. So x plus 3x plus 2x plus 90 degrees. And using that formula, it's 180 degrees times, there are 4 sides, so 4 minus 2. So what we have next is 6x plus 90 degrees equals 180 degrees times 2. 6x plus 90 degrees is 360 degrees. 6x equals 270 degrees, and therefore x is 45 degrees. And you could verify your answer by plugging 45 into all of those. Okay, letter B. I want to find x. I'm going to add up all of the angles. So start with our justification. Sum of interior angles of an n-gon is 180 degrees times the quantity n minus 2. And once again, n meaning some polygon with n sides. Now in this case here, if we count the sides, we have 6 sides. Also, a good way of checking is how many interior angles do you have? 6. The number of angles and the number of sides match. Okay, let's add everything up. Now I've got some repeats. I see 3 angles that are x minus 6. And we have 3 angles that are 2x. That'll save me some room from writing everything out. And then I'm going to write 180 degrees times 6 minus 2. Now make sure that you write this expression here, 6 minus 2. Don't just jump straight to 4. Show me how you know that that's going to be 4. Okay, so we get 3x minus 18 plus 6x equals 180 degrees times 4. 9x minus 18 equals 720 degrees. That should be degrees. 9x equals 738 degrees, and x equals 82 degrees. Okay, letter D. I'll do one more here. Now, it's a regular octagon. Now, remember, regular means all of the sides are congruent, and all of the interior angles are congruent. Well, if all of the interior angles are congruent, then every angle must also be 3x as well. Okay, so little note to ourselves. So a regular polygon has congruent sides and congruent angles. Okay, so we want to solve for the interior angles. So we'll write our justification. Sum of interior angles of an n-gon is 180 degrees times the quantity n minus 2. Now it's an octagon, and you can count the sides. We have 8 sides, so I'm going to write 3x times 8 equals 180 degrees and the quantity 8 minus 2. So 24x equals 180 degrees times 6. So 24x equals 1080. And divide by 24, x equals 45 degrees. Okay. I'd like for you guys to try the other 3, but we're going to move on to the last part of this activity. Okay, in a way, kind of working backwards. Now, suppose you actually know the sum of the angles, but you do not know the number of sides. Describe how you'd find the number of sides. Think for a moment. I would say pause the video, think about it to yourself so you can own the discovery, and then come back to it. Okay, so hopefully you thought, well, I kind of undo the formula. if 180 degrees times the quantity n minus 2 equals the sum, and I know the sum, then I'm going to work backwards. So, you set 180 degrees and then n minus 2 equal to 2,520 degrees. Then solve for n. Okay, let's do that over here. So, justify first. So, sum of interior angles of n-gon is 180 degrees times the quantity n minus 2. Okay, so 180 degrees times n minus 2 equals the sum of those angles. Divide by 180, so n minus 2 equals 14. Add 2, n equals 16 sides. Okay, make sure we label sides so we have context to that. Okay, I'm going to do one more example. Find the number of sides of a polygon that has the sum of the interior angles listed below. Okay, so I've given you the sum. Work backwards to find the number of sides. Okay, let's justify first. So, sum of interior angles of an n-gon is 180 degrees times the n minus 2. Okay, so 180 degrees, quantity n minus 2 equals 3,420 degrees. Now some people might multiply by 180, they'll distribute, which is fine. I tend to just go ahead and divide by 180 first. So I get n minus 2 equals 19. Add 2, n equals 21 sides. And make sure you label sides. Okay, I'll have you guys do the rest of the practice.